Hello guys, welcome to today's video. In this video we are going to talk about a branch of calculus called differentiation. Another differentiation we are going to talk about function of function, also known as chain rule. Now the formula for function of function or chain rule is given as dy dx, which is equal to dy du times du dx. Okay, we're going to take an example under this. So, we have a function given as y is equal to 3x plus 2 all to power 4. Now, when we have something like this is how we solve using chain rule or function of functions. Now, we're going to say let u be equal to the equation in the bracket, which is 3x plus 2. So our y will become, since u is already 3x plus 2, so in place of this we are going to put u power 4. So we are going to look for u with respect to x and y with respect to u. So it's going to become du dx is equal to, when you differentiate 3x plus 2, if you differentiate 3x, it will be 3, which is x raised to the power of 1, 1 minus 1 is 0, and x raised to the power of 0 is 1. And when you differentiate a constant, it turns 0, so we're going to have 3 here. And when we differentiate dy du, we're going to have 4u power 3. So putting it into the equation, which says dy dx is equal to dy du times du dx, we're going to have our dy du is 4u cubed multiply du dx is 3. So when we multiply 4 times 3, we're going to have 12u cubed. And you recall that our u is equal to 3x plus 2. So putting it into this place, we're going to have 12 into 3x plus 2 all cubed. So this is how we differentiate using the function of function. We're going to take another example. Okay, another example, which is given a function y is equal to x squared plus 1 all raised to the power of 5. Now we're going to say let u be equal to x squared plus 1, then our y is going to be u up power 5. So differentiating u with respect to x and y with respect to u, we're going to have du dx will be equal to, differentiating this, we're going to have 2x, then differentiating the y du, we're going to have 5u raised to the power of 4, which is say 5 is going to multiply this place and subtract 1 from the power, so it's going to become 5u raised to the power of 4. So using the formula of function of function, which is the y dx is given as the y du multiply du dx. So the y du is 5u power 4 multiply du dx, which is 2x. We're going to have 5 times 2 is 10 x u up power 4. But recall that u is equal to x squared plus 1. So in place of u, we put our equation. So therefore, dy dx is equal to 10x into x squared plus 1 power 4. So this is how you solve for this, also using the function of function. We're going to take another example also. Okay, taking another example, which says given an equation u is equal to the root of x squared plus 4. We can rewrite this as y equal to x squared plus 4 raised to the power of 1 over 2. This simply means the root of this. So I'm going to say let u be equal to x squared plus 4. Then our y will be equal to u all raised to 1 over 2. So now we're going to differentiate u with respect to x and y with respect to u. So we're going to have du dx. When you differentiate this, we're going to have 2x. So with respect to y with respect to u, which is dy du, will be equal to half. We multiply the coefficients here, which has become half u. Then you subtract 1 from half, we're going to have minus 1 over 2. So now taking the formula, which is the y dx, which is equal to dy du multiply du dx, which is going to be dy du is half u negative 1 over 2 times du dx, which is 2x. Multiplying these two, we're going to have half multiply 2 is 1, so there's no need for that. So we're going to have u raised to the power of negative 1 over 2 x. So this is going to be, but we should recall that u is equal to x squared plus 4. So therefore dy dx is given as x squared plus 4 all to the power of negative 1 over 2x. So this is the answer when you solve for this. I really hope this video is really helpful.